Oh.
Plug it in.
So yeah, I will give you guys an extra day of practice. If you're like, hey, I'm feeling awesome with this, Miss Alexander, I'd rather have like an extra challenge instead of like repracticing the same stuff. I can do that for you. Please just let me know. But okay, a rock thrown vertically upward from the surface of the moon is this position in meters for T seconds. How long did it take the rock to hit the ground? Okay, if I want to know how long it took to hit the ground, what is the position when it hits the ground? Zero. It's the height of 0, right? So I set the position function S of t equal to 0. So I'm going to say 32t minus 0.8 t squared equals 0. Then you solve it for t. So you factor out a t and you get 32 minus 0.8 t. That each one equal to 0. Hey, do you guys understand? We're gonna chop off t equals 0 because I mean that's the starting time of 0 seconds, right? So then you just solve this one. 0.8 t. So t will basically equal 32 over 0.8. That becomes positive. Negative over negative, right? So negative over negative becomes positive. So that is
40.
What is that? 40. Yeah, 40. And my units are seconds. Make sure you put units. Is that good? All right, ladies and gents. How do I find velocity in terms of time t? Given position, you derive, yeah. Velocity is the derivative of position.
Yeah.
So, but what did I ask for? I only asked for it in terms of t. So I just want v of t. Do I even want you to do anything else with that? No, not right now. So v of t is the derivative of position. So that's just 32 minus, hey, 2 times 0.8 is 1.6 times t. Subtract 1, right? Is that what you got for velocity? It's just the derivative of position. You just got to remember that. And then I don't have to do anything else with that, right? If it would have said, hey, what's the velocity when it hits the ground? Then I'd have to plug in 40 seconds for t, right? But I didn't ask that. In number 3, find the rock's acceleration as a function of time. How do I find acceleration? Acceleration is the derivative of velocity, right? So while s prime of t is velocity, s double prime of t is the derivative of velocity, which gives you acceleration, okay? So derivative of that is just negative 1.6, okay? I want you to write proper units. What are the units for this acceleration?
Meters per second squared.
Meters per second squared. You get that from it's the units of y over the units of x. The units of y are meters, and then per second. Velocity, the first derivative is meters per second. Acceleration is meters per second, or a distance per time squared, whatever those are. It could be feet per second squared or whatever. Okay? All right. That's the acceleration. Did anybody figure out what number 4 was? How long does it take the rock to reach its highest point? Anybody know? Let me help you with the visual. So if the rock is like going like this, right? Bless you. And after 40 seconds, it hits the ground. I really want to find the time that it takes to reach the highest point, right? So what do I know about the derivative? Do you guys know what the derivative is of, if this is s of t, what's the derivative at this point? What's another word for derivative? The instantaneous rate, that's not going to help us for a graph necessarily. Also the slope of the, what is the slope of the tangent line? Draw a tangent line. What kind of line is it at this point?
0.
A horizontal. So yeah, it's 0, right? So listen, the derivative is 0 at a max or min. Basically, what's the derivative of position again? Derivative of position is velocity. So basically you need to set the velocity equal to 0, right? Because think about what you do on a roller coaster. You go up, and you're kind of stopped, and then you go really fast, right? So your velocity is 0 at the peak or at the max or min. So you're going to take the velocity function, 32 minus 1.6 t, and set it equal to 0. And you have 1.6 t. I'm just going to add this, right? And then flip it, add 1.6 t, flip it around, divide by 1.6. So 32 over 1.6 is, it's going to be like 20. 32 over 1.6 is 20 seconds. So we know that at the 20-second mark, it reaches its peak. Oops. Is that good? All right. Here's what you're going to do. So this is a different kind of a worksheet. And if you had questions on, how did the worksheet 5 go for you guys? Did you guys do that one? Okay.
But now I understand.
Okay, I can come around to answer individual questions. So what I'm having you guys focus on today is 2.1, 2.2 circuit training review. Go ahead to that. For the first part of it, for 10 questions, you'll see these boxes, right? There are 10 boxes. And what you do is you start with number 1 here in this top front box. You get its answer, and then you hunt for the answer, and you find the answer wherever it is, and that will be the next problem you have to do. So like whatever answer you get, you find that in one of the boxes on the front and back, and then that's the next problem. And then it has like the answer there for you, so you kind of know, hey, I think I'm doing this right. And if you don't get something, let me know. I can help you out, okay? So that's the first part of this. That's the circuit training. So that'll all kind of work itself around. So when you get to number 10, number 10's answer will be like listed in number 1, right? So it says number 1, this will be number 10's answer, okay? So it should all kind of wrap around like a circuit. Make sense?
Wait, so what does this number represent? The answer to this problem?
That would, so the answer,
Like what did these numbers? It says answer.
okay, so like,
Equal 1.
that's gonna be the answer to one of the questions in no particular order, right? So that you just have to like find the, let's say you get like -1 as an answer, right? That means over here, I'm like, oh, I see -1. That means that's correct. And then I also need to do this problem next. And then whatever that answer is, I find it in the next box. Yeah? Okay.